Hey guys, how you going? I just want to talk you through this Newton's second law practical as best as I can. Look, before we're going to go anywhere, I have to apologise about the hair. I can't do anything about it, so the quicker we get over it, the quicker we can just move on and get this practical out of the way. So you've got this one. Hopefully you've got your results by now. So your results were obtained in the practical you've got in this table here, and you've hopefully got the mass of the trolley. Now all three trolleys that we used had a different mass. So you need to make sure that you have the mass of your trolley in your experiment. Now you need to hand draw the graph for this one. This video is not going to cover how to draw a graph. So if you need assistance with that, the best thing to do would be to ask your teacher. What I want to go through in this video is to help you guys to write the introduction and to help you write the discussion. Okay. Now the way I'm asking my class to submit these is to just hand up this part that you've done in the practical, so done by hand, and then I'm going to get my guys to hand all of this up as a separate sheet. Okay, so the introduction and discussion on a separate piece of paper. Gee, this is bad. Oh well. So sorry about that. I would make something like this and, like I said, print it out and attach it. Okay, so as I'm going through here, I'm just going to highlight what I'm talking about. And then maybe if you know how to do that part, just skip through the video until you get to the section that you want to work on. Okay, so that'll help you to find the bits and pieces that you need without having to watch the whole video. Okay, so the aim's the first thing we're going to work on. The aim is really simple. The aim is actually on the task sheet itself. So all you need to do is to copy and paste this to investigate the effect of force on the acceleration of an object, and your aim will be done. Okay, so that's all you need to do for aim. The second part are variables. So the independent variable, you want to say what you actually changed in the experiment. Okay, now the key to finding the independent variable, you can just look at the results table. Okay, so what we changed was the hanging mass. Okay, but in order to kind of get the units in terms of Newton's second law, in terms of what we want to have the hanging mass converted to a force. Okay, now weight is a force, and weight is the mass of the object multiplied by its effect on gravity. Okay, so it's going to be 0.1 kilograms multiplied by 9.8 meters per second squared, so F equals ma. Okay, so that's going to be 0.98. So hopefully that's no surprise for anyone. So this will be your independent variable. Okay, so put that in here. Now that's a sea level in order to be able to identify what the independent variable is and have the units. Okay, make sure you have the units, so N for newtons. What I would like you guys to do is to explain how that independent variable was controlled or manipulated. All right, and I want you to do this for all of the variables. So, how did you change the independent variable? Now, it's pretty simple based on what we actually did for the experiment. What did you actually change? So you changed this down here. We were changing the hanging mass. All right. So by adding additional mass, we were applying a greater weight to this trolley, so the force was increasing there. Okay, so just explain that in your introduction, just a sentence to say what you did. Okay, now the dependent variable is what we measured. So what did you actually record down? Again, we'll go back to the results table, and we're recording acceleration data. Okay, so you've got acceleration 1, 2, and 3, and then we average those out. Okay, so this will be your dependent variable. I won't spell it out for you, but it's right there. Okay, just make sure you get the units as well. And again, how was that manipulated? How did you measure it? Okay, now I don't want you to say we got a number and wrote it in. How did you get that number? Okay, what did you do in the practical to obtain that acceleration value? It involves one of these things that I'm talking to you right now, okay, and a certain computer program that got data. How did it get the data? It has to do with this thing, okay. I'm not going to spell it out for you, but use that information and just write that sentence for your dependent variable. Guys, controlled variables, I would try to have 3. So what are some aspects of the practical you tried your best to keep the same as you did this practical? Okay, it could be to do with the position of the cart, it could be to do with how the the data was obtained. It could be to do with how you kind of worked as a team in order to maybe count down 3, 2, 1, go. There's a whole bunch of things you can think of. Just try to pick controlled variables that will actually keep the experiment consistent as much as possible, because the whole point is to try and eliminate any or minimize any source of random error. Okay, an example of a really lazy controlled variable, would be using the same string every time. I mean, yes, we are using the same string every time, but you wouldn't go out of your way to change the string for no particular reason. Okay, what were the things that you were trying your best to keep the same that would really affect that experiment? Okay, so that's your controlled variables, and that will be your sentences for your variable. Guys, your hypothesis is really easy. So that's your prediction. Here, the reason why it's easy is because I've got it here for you. Okay, the acceleration of an object will, and I would put increase. Use the words increase and decrease. Will increase if the force applied to it is, and then you predict increased or decreased. Okay, that's your that's the way that you want to have your hypothesis. So just copy paste that there. Now for your hazards or your risk assessment, there weren't too many risks associated with this practical, but you just want to be aware of the things that you want to think about when you're conducting the experiment, and the teachers want to see that you've given that a little bit of thought. Now the way that I would tackle this is to have RIP. Now I stands for risk, and injury, and prevention. Okay, so what was the risk that we're focusing on? Okay, an example might be the trolley falling off the table. Okay, what injury could be caused by that? I'll leave that up to you. And what is a preventative measure to make sure that that risk doesn't happen? Now, something really simple might be just to have a specific person stationed at the end of the table whose job it is to stop that car. Okay, so if you do 2 of those, then you've completed your risk assessment. Okay. All right, now up to the harder part, which is the discussion. So using the evidence or data from the graph or table, describe the results. Attempt to explain the results. Now this is a 2-part question, obviously. Okay. By the way, for a discussion, I would set them out like this, and when I answer the question, delete the sentence. Okay. So I don't want it as question answer. It's better to have it in paragraphs. These are guiding questions that you don't, if you answer all of them to the best of your ability, then you're doing really, really well. Okay. So attempt to explain the results and describe the results. So if you want to look at your table, you want to go here. Okay. So you want to compare your acceleration averages. Now I don't have any here, but the general trend is that they will increase as the force applied will increase. So that's the really basic trend. As the force or the weight increases, the acceleration also increases. Okay. Now you can use your graph as well. If you have a graph and you have kind of a line of best fit, you can talk about what type of line of best fit you have, whether it's linear or exponential, so curving upwards. Okay. You can discuss whether it's a positive or a negative slope. So positive is sloping upwards and negative is sloping downwards. You can talk about the strength of the correlation. Now, the strength of the correlation means essentially how close the data points are to the line of best fit. All right. Attempt to explain the results. You can keep it relatively simple. You just want to explain why the acceleration would increase as the force applied would increase. And remember, we're talking about Newton's second law. So if you can incorporate that law at all, so F equals ma, and the rearrangement, which I'll talk about in a minute, use that if you can. Okay. So the second one is calculating 3 theoretical accelerations of the car based on its mass and the 3 different forces. Okay. Now, the acceleration equals the force divided by the mass. Okay. Now that's a rearrangement of Newton's second law. So F equals ma can be rearranged to A equals F divided by m. Okay. That's in your formula sheet. Now, if you're talking about theoretical acceleration for run number 1, okay, it will be the force applied to the cart, which is this, divided by the mass of the trolley. Okay, so whatever the mass of your trolley is, okay, just say it's 0.818, I just made that up, then you divide those two and you'll get an answer. Now that answer, I'm going to do this quickly. Okay, 1.20. Obviously rounding it. Oops. Okay, so we've got 1.2 meters per second squared, 1.20, and you calculate that for the other two as well. So the second theoretical acceleration will be this value in here divided by this value here, and the third theoretical acceleration will be the third weight divided by the mass of the trolley. Okay, so once you've got those, you compare those to your actual accelerations. Now I'm just going to make one up here, just say it's 0.80. Okay, they should be a little bit lower all the time. So comparing them just means what's the difference. So you could say for the first one there's a difference of 0.4. Okay, so just comparing them. That's basically all you need to do for that. So just do the calculation. You do the KEV-C method like we've done in class, and then just have those three, and then a brief comparison to what you got, and you might just have a general trend of what you got. So by how much do these results differ? You may have covered that in the previous question or the previous section, so you don't need to cover it twice. Just doing the subtraction and figuring out the difference in the accelerations between the theoretical and the actual. Now, why do these results differ from the accelerations you measured? Okay, there's a force that comes into play between two surfaces rubbing together. I won't spoil it and tell you exactly what it is, but it starts with an F and ends with a friction. So if you kind of add those together, you may be able to figure it out. So that force isn't taken into account with the theoretical acceleration, so these ones, but friction is in play with the experimental calculations, which is what you have here. Okay, so this is the real life stuff, and this has friction. I spoiled it. I told you it was friction. This theoretical is the perfect world where nothing goes wrong. Okay. Now physics, we often talk about that perfect world where there's no air resistance, no friction. Okay, but that is in real life. That happens in real life. So, why do they differ? Due to forces such as friction. Air resistance would play a tiny, tiny part, but mainly friction between the wheels and the floor, and maybe the axle and the wheel, and that is actually slowing the car down. Okay, discuss the precision and accuracy of your data. Now, precision is the difference between trials. Okay, the difference between trials. 1, 2, 3. So you need to look at that. All right. If your trials are really close together, that means you are precise. Okay. If your trials are far apart, that means you're not very precise. Now I want you guys to make a judgment call on how precise you are. Okay. Use the numbers, do a difference, do a subtraction, and you make a call. You can say low precision, moderate precision, or high precision. Okay. Maybe you're high precision for the first run, but low precision for the second run, and maybe moderate for the third run. That's okay, you can say that. But as long as you can identify what precision is, that's what we're looking for. And use your numbers as well, use your data, okay? Don't just say, oh, we were moderately precise with no use of data to back up that claim, okay? So make sure you say that. Guys, accuracy is how close you are to the true value. Okay, now the true value is this, the theoretical acceleration. That, I don't know why I'm pointing in the air, but I am. That means when I really mean business. That's the true value. Okay, So how close are you to the true value? Again, it's a judgment call. You can say very accurate, you can say moderately accurate, you can say low accuracy, high accuracy, not very accurate. Up to you, but use your data again, okay? If that's 1.2 and this is 0.8, I would say accuracy is moderate to low. There is a 0.40 difference between the theoretical and the actual, okay, or the experimental. So have a judgment call for that. The errors, okay, random and systematic. Now this is you can write a lot in here, okay. I'm happy for you to do one error really well. You don't have to do 5 or whatever. Just do 1 or 2, but do it well. Okay, do it well. No pressure. So the random errors are errors that can come into play in any one of your runs. Okay, you did it 9 times, and it's an error with how the procedure was carried out that can change these numbers. Okay, random errors play a large role in your experiment if your precision is low. Okay, so just say I got like 0.7, 0.7, 1.2. Okay, now that stuffs that up, but let's just pretend it doesn't. So between these two, very similar. So obviously there wasn't much random error that existed between here and here. There wasn't much difference, okay, because these are pretty similar. But this third one, it looks like some random errors may have taken a part in that, okay, because that result is quite different from these ones. So what's something that could have happened throughout the experiment that could cause a random error? Now I'm going to leave that up to you guys to figure out, but I mean, we're getting a result based on how fast this is spinning, which is dropping this, okay? Now that can only really drop so far, but there's so many things that could go wrong here, okay, between the difference. That needs to be really straight. Look, I'm going to leave it at that, but you can talk about maybe the orientation of this trolley, and yeah, so what could happen and how it could cause that random error, okay, and how that could affect the results. Guys, a systematic error is an error with the system. So there's something with the equipment that is causing your result to not be similar to the true value. Okay? So with a systematic result, it affects all results equally. Okay? So all of these values are going to be off of the true value if there's a systematic error. Okay? They all might be lower or they all might be higher than what's expected. Now, based on what's expected, I'm going to tell you that should be higher than what you got, okay? That should be higher than what you got. So there should be a systematic error in play that makes all of your results a little bit lower than they should be. What might that systematic error be? We discussed it previously, the main one, okay? The forces that are in play in the experiment that aren't in play in the perfect world where there's no interference, okay? So that's the main source of systematic error that you want. Okay, suggest one way to reduce the effects of random errors in the experiment. Now there's a couple of ways you could approach this question. You could talk about something that you did in your group that really tried to keep everything the same, okay? Maybe a method that you did, something that you did that you worked well with to make sure that random errors that could stuff things up were minimized, okay? You could also talk about this, okay? The fact that we got 3 for each run, all right? The sample size is 3, and this was calculated. So that's something you could talk about as well. To identify a systematic error in the experiment, what could you do? So if you've got, how do you know if there's a systematic error? How do you know that all of your results are a bit lower than they should be or all of them are a bit higher than they should be? Okay, it's got to do with repetition, repeating the experiment on a new day with new equipment, comparing results to the previous day and making sure that if there's a difference. Because if you did it again with different equipment on a different day, and all your numbers are higher or all your numbers are lower in the second time than the first time, then you could say, there must have been a systematic error on one of those days. So you can identify that there's one there. You can't get rid of it, maybe, but you can identify it. So that's the key there. Okay. So suggesting an alteration is a modification to the procedure or the equipment that will result in a more valid data set. Now, valid data set means better numbers, numbers that you can trust more. Okay. Explain how it will achieve the effect. So I really want you to think about how could you make the experiment better. There's so many ways you can make it better, so many ways. I mean, if you just think on a really basic level, what were the conditions of the trolley like? Were they just brand spanking new, straight out of the packet, or were they a bit, used, a bit worn, that kind of thing? So if you had, perfect kind of vehicle that would always had the nice wheels. One of the trolleys had a chip in the wheel. If you had something that you could just count on the fact that it will go nice and straight and minimize that friction, that might give you better results already. So something that could do that. Okay, think of something really different, really unique, really interesting. Okay, if you think of one that's kind of boring, that's not as good as one that thinking out the square. We want to see some really impressive thinking in this one. Okay, so that one, yeah, just something that will improve the experiment. What effect would you expect an increase in the mass of the cart to have on its rate of acceleration? Okay, now acceleration equals force divided by mass. Okay, you can use that equation in order to figure out this answer. Alright, you can insert arbitrary numbers for force and mass. Okay, so just say I've got, I don't know, 5 for force, divided, 5's too hard actually, 4 divided by 2 for mass. Okay, then the acceleration would be 2. 4 divided by 2 is 2. Okay, if you increase the mass, let's make the mass, instead of 2, let's make it 4. So 4 divided by 4 is 1. So obviously if you increase the mass, you're going to decrease the rate of acceleration. And that makes sense. If something gets bigger, it's obviously not going to accelerate as fast. Okay? How does Newton's second law influence things in your everyday life, specifically cars? Okay. Now you might need to do some Google research here. What's the point of Newton's second law? You could have gone through all of this and not had any idea what Newton's second law is, to be perfectly honest. The fact that the force applied to an object, the mass of an object, and the acceleration that it experiences, they're related somehow, okay? And we've kind of explained that here a little bit, all right? So the acceleration experienced is influenced by the mass of the object. Now cars, cars have mass, they weigh something, they move, okay? So a force is applied to cars through the engine, through the burning of petrol in order to get the car moving, okay? Because there's chemical energy in the petrol and that will burn and that will make the engine move, it will make the car move, okay? I'm no mechanic, I don't know how everything works, but I know that the energy is from the petrol, okay? And that force provided through that engine is making the car move, it's making it accelerate, okay? So what do engineers maybe have to think about with the mass of a car, how much it weighs, when they're considering how it works, okay? Think of things like fuel economy, all right? Fuel efficiency. You know how we all, or your parents might, well, you guys will be soon, you'll be driving soon, complaining about how expensive petrol is. I got a new car recently and I get so many more kilometers because it's more fuel efficient, okay? So have a think about that. What is the importance of the amount of force applied and where does the energy come from in a car? Now I just kind of covered that before, where the energy comes from, from the servo. So talk a little bit about, that fuel, where there's energy in there. So there's a bit of an overlap here with energy. This is kind of extension stuff, by the way. So if you're not too amazed with your responses here, that's okay. All right, just try your best. What is the importance of the amount of force applied? That's got to do with how much acceleration is being experienced. Why is it important to keep the mass of cars low? I kind of covered this already, so it's to do with fuel efficiency. Okay, Guys, I'll wrap it up here. Thanks very much for doing all that hard work on the report. I really appreciate it and look forward to seeing you guys in class.